welcome to Edu Ideas. Great ideas come from great teachers. Okay guys, for this video I'm going to explain, I'm going to discuss about the review that for the unit test that we will have next week. And the topic that we're going to have is Cartesian coordinates, and then function, and then straight line, which is like slope, and then a straight line equation, and then also the simultaneous linear equation. So okay, so let's just start from question number 1. So I have a couple of questions here that I'm going to discuss with you guys in this video. And for number 1 here, the question is state the coordinates for each of these points. So actually it's quite easy, right? So remember that the first thing that you need to know that the horizontal line, horizontal axis, we call it the x-axis, and then the vertical axis, we call it the y-axis. So, and then the coordinates should always be in the form of x comma y. Yeah, so don't get mixed up with the y and the x. Okay, so let's just start from point A here. So point A, so how can you find the coordinates? It's quite easy. You just like, okay, point A here, let's go to the x-axis here, which means that we're going to go down here, which is 1, so that is the value for the x, and going to the y-axis here, we get the 3, so the coordinates is going to be 1, 3. Okay, so be very careful guys, this is comma, not point, because if you use point is for decimal, comma is to separate the x and the y for the coordinates. Okay, so B is also the same. This is like 4, 1, and then C is minus 3, 2. Don't forget that this one first and then this one, right? And then yeah, you can do the rest one. I'm gonna state a couple of points that you might sometimes you miss. For example, like this f over here. Okay, this f over here, the x is minus 3, right? And whenever a point is on the x-axis, then the y value will always be 0. So this is minus 3, 0. And the same thing with the h, right? So the h is on the x-axis, so this is 2 is from here, and then comma 0, right? And then the g, right? This g and this I point, both of them are in the y-axis, so this is 0, 5. So whenever a point is on the y-axis, then on the y-axis, then the x value will be equals to 0. So this is also 0, minus 1. Okay, and then for the last one, this one is j. This we call it the origin, and the origin always 0, 0. Okay, so that is for the question number 1. Question number 2. Given a function f(x) is equal to 2x minus 7, determine the value of f of 3 and then f minus 4. So basically it's quite easy. So what you need to do is just like, because we know that this is the function of x, right? So this is going to be the value of x, so you only need to substitute this x by 3, as easy as that. So this is equals to 2 times 3. Remember that you should always put a bracket when you substitute that x, whatever variable that is, right? This is the x variable, then you put a bracket, because sometimes when you have like a subtraction inside, I mean you have a couple of terms inside the bracket, it will be, sometimes the calculation will be a little bit different. Okay, so next one is minus 7, right? Because we only need to, like, again, substitute this x by 3, you get this one, and then you get 2 times 3 is 6, 6 minus 7 is equals to minus 1. As easy as that. Okay, so same with this one. So this one will be 2 multiplied by minus 4 and minus 7, right? So again, you only need to substitute the x by minus 4, right? And then that will be to minus 2 minus so 2 times minus 4 is minus 8, minus 7 equals to minus 15. Yeah, right? Okay, for number 3 is the same thing, but in this function you have a couple of x. I mean, like, it's not just one term that has an x. For this one, you have an x. This one is x squared, and this one is also x. So, but the basic concept is still the same, right? So you only need to substitute that x with 4, right? So I'm going to substitute that. So that will be equals to 4. And remember, if you use bracket, square minus 4, because we have a square here, right? So don't forget the square there. And then we have minus 4 and then minus 12. That will be 4 squared is 16. 16 minus 4 and then minus 12, that will be equals to 0. Okay, next one. Previously you were finding the value, right? So for this question here, the next question is the new expression So, but the same thing, guys, when I have this here, right, this 2x inside this bracket, so what you need to do is just like change the x in here into 2x. But remember that every time you do this, you put brackets, yeah, okay? So let's do that. So the 3, okay, I'm gonna highlight that a little bit. So the 3 stays here, okay? So that's 3. So I'm gonna put the 3, and then that fx will become, so I put a bracket on it. So I'm just like using these, right? But I change this to x by, sorry, this x and this x by 2x. Okay? So let's do that. So we will have 2x squared, right? For this one becomes 2x squared, and then the next one is minus another bracket 2x, and then minus 12. Okay, as you can see that I'm just substituting this guy with this, and then this guy with this, right? So that's the only thing that I did there. Okay. And then this is equals to put the 3 there, something. Okay, 2x squared. Remember that this is different if I have 2x squared and 2x squared. This is different. When I have like something like this means that this is 2x multiplied by 2x. 2x multiplied by 2x is 4x squared, right? So be careful with that. Okay, so I'm gonna write that down here. So this is going to be 4x squared. That will be minus 2x and minus 12. And then because I have a bracket and I have 3, so you only need to multiply that 3 and distribute that to all of the terms inside the bracket, right? You multiply it like this. Okay, so that will be 12x squared, and then minus 6x, and minus 36. And there you go. You have the new expression for this. Okay. Next up, number 4. Given a function of x equals to 2x squared minus 3, determine the value of a if a is equals to minus 1. Again, the concept is still the same, guys. Yeah. So if I see I have that function of x, right? So basically I'm just like changing the x into a. Okay, so if I change that, have to substitute that with the a, so I will get, sorry, I'm gonna highlight the x here. Okay, so I will get fa, right? So fa, f of a is equals to 2a, right, square minus 3. So again, like you see before, I'm just like substituting this x with this a, right? That's it. Okay, so I can open that bracket, so it becomes 2a squared minus 3. And that will be equals to minus 1. Where do I get the minus 1? From the question here, equals to minus 1. So I can write this down as equals to minus 1, equals to minus 1, right? Based on this one over here. Okay, so for this one, it's quite easy because you only need to solve this, just like, you know, like 2a squared equals to minus 1 plus 3, right? And then you will get 2a squared is equals to, like, this is minus 1 plus 3 is 2, and then a squared is equals to 2 divided by 2, and a squared is equals to 1, so a is equals to square root of 1. So that will be plus minus, sorry, this plus minus 1, yeah? So why is it plus minus? Because 1 times 1 equals 1, and minus 1 times minus 1 is also equals to 1. Because that, which means that we have two answers, which is plus 1 and minus 1. Okay, so be careful if you have like a quadratic. Okay, so let's go to the next question. Here would be the same exact concept. Okay, you can do it by yourself, right? You do the same concept. I would like you to try for B, yeah? This one here. The same exact method like number 4A. Okay, next, number 5. From the image below, state the gradient of line AB. So remember that gradient is denoted by the letter M. Is as easy as rise over run. So it's like the vertical change over the horizontal change. Okay. So whatever you do, whenever you want to find the gradient of a line, so pick 2 points, 2 distinct points on the line, right? So whatever you wanted, but the easiest way is to find the easiest coordinates. For example, for this one, I have given you these 2 points, right? Those 2 points are quite easy to see because you can say that it is intersecting the grid, right? This one, A, B. So the easiest way to do this, if you don't want to use coordinates, you just like make a right angle triangle. So from A to B. So I'm gonna start from A, here this, and then I'm going to go there as the rise. Okay, there we go. So rise means that is going to be the vertical change. The run means that it's going to be the horizontal change, right? Rise is going up and down, right? Run is going horizontally. Okay, so which means that this is going to be the rise and this is going to be the run. As easy as that. So we only need to count, measure the the length. Okay, so in unit we have like 1 2 3 4. The rise is 4 and the run is 1 2 3 4 5 6. Okay, so that leaves, that is going to be 4 over 6. And remember that because this is going uphill from the left to right, then the gradient will be positive, right? So 4 over 6, we can simplify that, becomes 2 over 3. And there you go, you have the final answer. Okay, for number 6, same question actually, but just different line. And then from the state the gradient, of course, so the same thing, we have rise over run, right? And then you can again draw a rectangle triangle, right, from point A to point B. So I'm gonna do that. So I have this over here and goes here, and then goes over here, going down like this. Okay, but again, be careful, guys, because we know that this line is going downhill. Okay, from the left to the right, going downhill. So which means that the gradient will be negative, right? Negative of one of something over something, right? So we do the same thing like before. We just measure the rise and run. So this is going to be the rise, and then this is going to be the run. Okay, so let's start from the rise. So we can start from here, like 1 2 3 4 5 6. So that's going to be 6, and the run will be 1 2 3 4 5 6 7 8 9. Okay, so the gradient will be minus 6 over 9, or we can simplify it, it becomes minus 2 over 3. Right? Okay. Next question, number 7. Okay, state the coordinates of point A and B, the gradient, and the line equation. So this is like in the combination. It's not just the gradient, but also the points and then the line equation. Okay, so let's do that. So let's see the point A. Point A is minus 2 comma minus 4, right? Minus 2 comma minus 4. And then point B is 5 comma 2, right? 5 comma 2. Okay. Okay, that is the first question. Okay, and then the next one is the gradient. So for this gradient, you can do like you can pick any method you want. But if you see if you see a grid like this, if you see that it's easier to make a rectangle triangle, just make a rectangle triangle. But if you want to use the coordinates, you can do that. Okay, so I'm going to show you both ways. Okay. Okay, so for the first one, maybe you want to find it by just I'm just going to draw a rectangle triangle. So going that way, here, and then going that way, and there we go. Okay, so just calculate the measure the units. I mean, like the length. We have 1 2 3 4. That is for the rise, and we have 1 2 3 4 5 6 7 8 9. Okay, so the gradient, and again, guys, be careful that the positive and negativity of the slope, because this one is from the left to the right is going uphill, so this is going to be a positive slope. So it's just right over run, so it's 4 over 9. Okay, simple as that. Okay, or you can use the formulas that I've gave you, which is the y2 minus y1 over x2 minus x1. Okay, so how do we do this? How do we use this formula? Is just by determine which one is x1 and y1, which one is x2 and y2. Okay, so for this one, okay, let's say I'm going to use a as x1 and y1. So that means this is going to be x2 and y2. So actually you can choose this as x2 and y2, and this is x1 and y1. Actually it's the same thing, but don't do it like this. If this is x1, don't say this is y2. Don't. You have to say this is y1. This is x1. This is y1. Yeah, so the same thing. If this is like x2, you cannot have y1, right? So this is not correct. Okay, so yeah. Okay, so if I have those two numbers and put it, we only need to substitute that to the formulas. So we will get m is equal to the y2 is 2 and y1 is minus 4, right? And then the x2 is 5 and the x1 is minus 2. Right, so I get all of the numbers from here to these 2 points, right? Okay, so I'll get 2 minus 4 is 6. 5 minus 2 is equal to, wait, 5 minus wait, 5 minus, oh my goodness, wait. Okay guys, I think I made a mistake. Sorry guys, so this one should be, oh my goodness, this is 4, sorry, this is minus 4 minus 2. My goodness, sorry. Okay, so I'm gonna change that. So that will be 2 minus 2, right? and that one is 5 minus 4. Okay, my bad, sorry guys. Okay, that will be 4 over 9, right? So see, we have the same exact value of the gradient. Yeah. Okay, so the next one is the line equation. Okay, so the line equation here, you can use that y equals to mx plus c, right? So y equals to mx plus c. So this is the what do you call it, the common form that we use. Actually, there is another formula, but let's use this one. Okay, so we have that points, right? So we have this point here for this 1 point and this 1 point. Just choose 1 point. Okay, just one. It's up to you which one you want to use. So we can choose, I'm gonna use the positive value here, 5,2, and then I have that the gradient is 4 over 9. So I can have y equals to the m is 4 over 9, right? X plus c. So how do we find the value of c? Is just by substitute the y and the x by 5,2. So again, you can choose one of them. Okay, so that will be 2 equals to 4 over 9 times 5 plus c. Okay, so I don't have enough room, so I'm gonna put it here. So I will get 2 equals to 4 times 20 over 9 equals c. So c will be equals to 2 minus 20 over 9. That will be I assume it's going to be minus 2 over 9. I think so. Yeah, minus 2 over 9. So which means that the line equation, so sorry, I'm gonna put it here. Okay, the line equation will be y equals to 4 over 9x minus 2 over 9. So this is going to be the line equation. Yeah. Okay, so let's do the next one. The same questions but different line. So the first thing that we need to do is to determine the gradient. Okay. Okay. Be careful. Yeah. Okay. Again, the points here we have minus 2 comma 2. Yeah. Sorry. Yeah. 3. Yeah. Minus 2 comma 3. Yeah. Okay, and for this one is 2 comma minus 4. Okay, so 2 comma minus 4. Okay. Okay, and then after we determine that, we can use a gradient. And then if you don't want to use the formula, it's fine because you have this in the like in the image. You can just like draw a right angle triangle. This, right? Stop here and then going down here. Okay, so notice that the line from the left to right is going downhill, so which means that the gradient will be negative, right? So it's going to be negative. And then we can just measure the length. Okay, so 1 unit, 2, 3, 4. That is for the right, the run. And this is 1, 2, 3, 4, 5, 6, 7. Okay, so the gradient will be minus 7 over 4. Okay, that's the gradient. We have 1 point, and then we find the line equation. Okay, again, we can use the y equals to mx plus c, right? And then because we know that the gradient is minus 7 over 4, so we can write down y equals to minus 7 over 4 x plus c. And we can find the value of c by using one of the coordinates. Okay, so you pick. Okay, you can choose a or b. It's the same thing. Okay, I'm going to use the a this time. Okay, so I will get y is equals to 3, right? And then that will be equals to wait. Yeah, so that will be minus 7 over 4, and I'm going to change the x with minus 2 and then plus c, right? So I have to start from here. So I get this minus 2 from here, and I get this 3 from here. Okay, so let's do that. We have 3 equals to, for this one, it's going to be 7 over 2, right? Plus c. So which means that the c is going to be 7 over 2 minus 3. So that will be 1 over 2, right? Okay, so which means that we have a conclusion of, because we have y equals to mx plus c, and then we know that the value of the gradient is minus 7 over 4. That is minus 7 over 4x, and we know that c is 1 over 2. And then we're done. We get the line equation. Okay, next. Okay, next, number 8. What is the gradient of a line in which has the equation of y equals to 3x minus 5? So this is very easy because we know that the form that we have learned is y equals to mx plus c, in which in this form, right, where the y is alone on the left side of the equal sign, and then the coefficient of x is the gradient, right? The coefficient of x is the gradient. So since this form has the same form with this one, So which means that the gradient is equals to 3, as simple as that, right? So this 3 over here. That's it. Okay. For number 9, what is the gradient from the line which has an equation of this? So the question, the same exact question, but this time the form is not in this form. Okay. So how do we find the gradient? So let's change this into this form, right? So by like moving all of the things, all the terms which is not y to the right side, and the left on the y is still on the left side. So let's do that. We have 4y plus 8x minus 12 equals to 0. Okay, so that is the equation. So we are going to move this one here, and then we'll move this one here, and then we're also moving this one so that the y is alone on the left side. Okay, so let's do that by I'm going to move these two first. Okay, because the 4 we need to divide, so let's move that to the right side. You'll get 4y equals to, right? So the 8x becomes minus 8x, and minus 12 becomes positive 12 because this is 0, right? So get like plus 0, you still get the same number, yeah? So you don't have to write down plus 0. And then we still have this 4, right? So we need to get rid of this 4 by dividing all by 4. So you divide all by 4, okay? So y equals to minus 8x over 4, and the 12 also divided by 4, right? Because this is like we have like two terms, so these two terms need to be divided by 4. Okay, so that leaves us with minus 8 divided by 4 is minus 2x, and then 12 divided by 4 is equals to 3. So this is going to be the line equation. Okay, next up, number 10. Determine the gradient of the line which through these coordinates. Okay, so this is actually the same thing like we did before. So when you have only the points, right, you can use that what do you call the formula that m equals to y2 minus y1 over x2 minus x1. So basically this is just like the rise and the run, right? The rise is the change of the vertical, the vertical change, so the vertical, the y change, and this is the x change, which is the run, right? So basically we're doing the same thing. Okay, so let's determine which one is the x1 and y1 and x2 and y2. So I'm going to use this one and x1 and y1. This one is x2 and y2. So we can just plug those into the formula. So we'll get m is equals to 13 minus 5, right, over 7 minus 2. 13 minus 5 is 8. Sorry, 7 minus 2 is equals to 5. So there we go. You have the value of the gradient. So you do the same thing with b. Yeah, you can try it. Okay. Next, number 11. Determine the line equation from these pairs of coordinates and a gradient. Okay. So remember, guys, whenever you have a point and a gradient, it's quite easy, because you only need to put that into this form, right? Because this is the form that we have learned. Actually, we have another form, this one, if you know, but if you don't know, it's fine. X1 is x1, but if you don't know, you don't have to use this one. So, okay, so if we use this one, so because we know that we have a gradient of minus 5 and the value of x and y in one of coordinates that through the line is minus 3.4, so you can just plug all of them into this equation here, so that we can find the value of the c. Okay, so let's plug those in. We have 4 here, right? So that's the y, and then equals to m is minus 5, and then x is this one, minus 3, plus c, right? So you find to find the c. So 4 equals to minus 5 times minus 3 is 15 plus c. So which means that the c will be equals to 4 minus 15. That will be minus 11, right? So that will be the c. So which means that the line equation will be, because we know that it will be y equals to mx plus c, and because we know that the value of the gradient is minus 5, so it's minus 5x, and then we know that the c is minus 11, so we are done. Yes, quite easy, right? Okay, you do the same thing with b. Yeah, you can try it. Okay, next one, determine the line equation from these pairs of coordinates. Okay, so the same thing. For number 11, you have the gradient, and then you have a point. You can just go there. But for number 12, you need to find the gradient first. Okay, so we need a gradient and a point. Okay, so find the gradient by like number 9. Okay, so for this one, so I'm gonna put the gradient. That will be, this is x1 and y1, this is x2 and y2, then I will get 5 minus 4 over 2 minus 9. So 5 minus 4 is 1, 2 minus 1 is minus 7. So I will get like minus 1 over 7 as the gradient. And then choose one of these 2 points. Okay, just choose one. I'm going to choose this one, this B. Yeah. So if I choose that, if I put that into the y equals to mx plus c, right? And I'm going to choose that. So I will get, if I choose this one here, that will be 5 equals to minus 1 over 7 times 2 plus c, right? So I get the 5 from here, I get the minus 1 over 7 from here, and I get this 2 from here, right? And so this method is to find the value of c. Okay, so we get 5 equals to minus 2 over 7 plus c, so that makes c is equals to 5 plus 2 over 7. So that will be 37 over 7. Yeah, that is the value of c. So which means that the line equation, right? Because since it will be y equals to mx plus c, so because we know the value of m is minus 1 over 7, and then the c is 37 over 7, and then do that. Okay, so you can do the same thing with b. Try it for yourself. Okay, number 13. Coordinates of 2 points are a and b. We have this a over here, and then we have b. If the gradient of like segment is 2 over 7, so the gradient is 2 over 7, what is the value of b? As we know that when we want to find out the gradient, you can just use that formula, right? y2 minus y1 over x2 minus x1, right? So let's name this with x1 and y1. This one is x2 and y2. So you just plug in all of the numbers there. You will get 3 minus 1, right? 3 minus 1. And then over p minus 4, right? P minus 4. Okay. So I will get 3 minus 1 is 4, right? P minus 4 is going to be P plus 4. That will be equal to 2 over 7, right? Equals to 2 over 7. So how can we solve this? Just by using the cross multiplication. So the 7 goes there, and that's P plus 4 goes that way, okay? So if we do that, we get 4 times 7. Okay, remember that this is a multiplication, right? Equals to 2 multiplied by p plus 4. Remember that you need to put brackets, yeah? If you have like more than one term, it is very, very important to put bracket. Okay, so 4 times 7 is 28. And open that bracket to get 2p plus 8. And I'm going to put that 8 to the right side. I will get 28 minus 8 equals to 2p. So 20 equals to 2p. So p is equals to 20 divided by 2. That will be equals to 10. Right? Okay, next, number 14. Determine the value of x and y from these pairs of system of linear equations. So this is like the system of the linear equation, or we call it the simultaneous linear equation, or we find the intersection. It's the same thing. Yeah, we have these two lines and want to find the intersection, right, or the value of x and y, in which fulfill both of the equations. So we can use the substitution method, or we can use the elimination method. Okay, I'm gonna use the elimination method this time. So I'll write down 2x plus y equals to 9 from here, and then I'm gonna write down x plus y equals 5 from here. Okay, so I want to eliminate. So this is quite easy because if I want to eliminate, let's say I want to eliminate the y, right? I just subtract that, right? Because y minus y equals to 0. By subtracting that means that I'm eliminating the y. So subtract that, to x minus x is going to be just x, right? And then that y minus y is just 0. I don't need to write it down. And 9 minus 4 is 9 minus 5 is equals to 4. And then we get the value of x. And then since we are we need also to find the value of y, right? So when you want to find the value of y, you only need to put, substitute this 4 to the x from one of the equations. Just pick one, yeah? Which one? It's gonna be the same, yeah? So I'm gonna pick this line equation, right? So if I have x plus y equals 5, and I know that the value of x is 4, so just 4 plus y equals 5, so y equals to 5 minus 4, and y equals to 1. So which means that the final answer will be 4, 1. 4, 1. Yeah? Quite easy, right? Okay. And for B, okay, for question B, I'm going to use a substitution method this time. I'm going to substitute this y here, so this y here, by this guy, right? Because this is y equals to something, right? So I can just substitute that to there, right? So I can write that down as 3x plus 2 and then 5x minus 6. Okay, so Notice that what I'm doing is just like changing this y here becomes this 5 x minus 6 because it's y equals to 5 x minus 6, right? So minus 14 equals 0. So I can expand that bracket, becomes 3x plus 10x minus 12 minus 14 equals 0. So we'll get 13x minus 26 equals 0. So 13x equals to 26. So x equals to 26 over 13, and that will be equals to 2, right? Okay, and then the same thing, if I get the value of x, so to find the value of y, it's just like substituting to one of the equation. You can use this one, and you can use also this one, right? So find the easiest one. I think this one is quite easy because you only need to put the x there, and then you get all straight go to the y. So if I use that, I will get y equals to 5 times, because I know that the value of x is 2. So put that 2 in here, and then minus 6, and I will get y equals to 10 minus 6, and y equals to 4. Okay, so which means that we have a conclusion that the solution is 2, 4. It's 2, 4. Okay, next, number 15. Okay, so in a stationery store, the price of 2 pens and 3 books with the same brand and type is $21, while 3 pens and 2 books cost $19. So in here, guys, what you need to do here is to state first what is the pen and what is the books, and like the price of them in terms of x and y. Because we're using the Cartesian coordinates, let's use x and y. Actually, you can use other variables, but yeah, use x and y for this time. Yeah, so for example, like this, if I'm going to state the first one is the price, okay, the price of a pen is x, and then state another one, the price of a book is y. Okay, so I have that statement there. So I can write this sentence here with 2x, right? 2x from here, 2x, and then 3 books plus 3 books is 21, right? So I can write it down like that. So the same thing with the second sentence here, right? Where 3 pen and 2 books cost $19. So I can write that as an equation like this. So I can write that down as 3x, right? Like this 3 pen, because the pen is the price of 1 pen is denoted by x, and then 2 books means plus 2y is equals to 19, right? So I have these two linear these two equations, and then I would like to solve the question, because like using simultaneous linear equation. Okay, so for this one, I'm going to use the elimination method, but we cannot just go straight and subtract or add them, because we don't have the same exact coefficient for every x or for every y. Okay, so what you need to do here is to decide which one do you want to eliminate. Okay, so it can be x or it can be y. It's up to you actually. So for this one, I'm going to choose, let's say I'm going to eliminate the y. Okay, so if I want to eliminate the y, it means that these two numbers should be the same. So how can I do that? By finding the LCM of these two coefficients, which is 3 and 2. The LCM of 3 and 2 is 6, right? Oops, sorry. The LCM of 3 and 2 is 6, right? So which means that we need to make this into 6. This one is also become 6. How do we do that? By multiplying, right? It's not working, right? Yeah. By multiplying all of these by 2. If I multiply that by 2, this will become 6, right? 6y. And for this one, I'm going to multiply all of them by 3. Remember that if you want to multiply by 3, you need to multiply all of them by 3. This one, multiply all of them by 2. Okay, so that is what we're going to do. Okay. We only need to so we only need to multiply all of them. The first equation, this is the first equation, this is the second equation. The first equation, all of them by 2, and the second equation, multiply all of them by 3, and then we will get the new equation, which is, for the first equation becomes 4x plus 6y equals to 42. Okay, so I'll notice that I only multiply all of these by 2. Okay, so that will be the third equation, right? Okay, the fourth equation is just multiplying all of these by 3. Then I will get 9x plus 6y equals to, wait, 60 minus, so 57. There we go. Right, so if I have these two, this is going to be I mean, like, we can eliminate this by just let's say because I want to eliminate the y, so as you can see that if I subtract this and this one, that will become 0. By subtracting that, then we'll eliminate the y. Okay, so I'm gonna subtract that. We have 4x minus 9x becomes minus 5x, and 6y minus 6y is just 0, and then 42 minus 57 is 15, minus 15, right? Yeah. So which means x equals to minus 15 divided by minus 5, and I will get x is equals to 3. Okay. And then finding the value of y, just use the one of the equation. You can use equation 1, 2, 3, or 4. It's up to you. I'm gonna use the equation number 1. Equation number 1. So I will get 2x plus 3y equals to 21, and I'm gonna put that 2 so the x by 3. So 2 times 3 plus 3y, so this 3 comes from here, yeah? Okay, so that will be equals to 21. Then I will get 2 times 3 is 6 plus 3y equals to 21. So 3y equals to 21 minus 6, and 3y is equals to 15, and y is equals to 5. So which means that we have a solution of 3, y. Okay, next up, number 16. Okay, now determine the line equation of line which passes through point A and parallel to line this. Okay, so we have like two lines, right? We want to find out the value of the line equation, right? And then it passes this point, but it is parallel to this point. So let me illustrate that for you. So we have a point here. Let's say this point is like this, right? And the line is like this. This is L1. That passes through point A, right? This passes through point A, which is minus 5, minus 9. Let's say it's like this. And then because we don't know the gradient yet, right? But actually there is a other line. Let's say it's L2. Let's say L2 is in here, right? This L2. This L2, know that this L2 is parallel to L1, right? So by can we find the gradient value of L1? Just by finding the value of the gradient of L2. Since we know that if two lines are parallel, then the gradient will be the same, right? There we go. So because we know that we have this as the L2, right? So let's find the gradient of that L2, right? So we have 3x minus y equals to 8. So remember that when we want to find a gradient, the easiest way to do this is like to change the to convert that equation so that it will be y equals to mx plus c. Okay, so notice that if I move this here and I move that there, that will be 3x minus 8 equals to y, right? I'm moving this here and this one here, right? So I can just swap them, right? Y equals to 3x minus 8. And there you go, right? So which means that the gradient is this one, right? This is the gradient of this L2. So which means that because L1 is parallel, right? L1 is parallel to M2. So which means that the M1 is also going to be 3, right? Because M2 and M1 is parallel, they're going to have the same exact gradient. Okay, so since we have the gradient on the point, so you can find the the line equation, right? Because we have y equals to mx plus c for the L1, yeah. And then we know that we have the gradient of 3, and we have that minus 5 and minus 9, so we can put that this one to here and this one to here. Yeah. Okay, let's do that. We have minus 9 equals to 3 times minus 5 plus c. Okay, so minus 9 equals to minus 15 plus c. So that leaves us c equals to minus 9 plus 15, and that c will become equals to 6. So in conclusion, we can write down that the equation will be y equals to we have mx plus c, right? And then the m is 3, and then the c is 6. And there we go, we have the final answer. Okay, next question. Okay, so next question number 17. So determine the line equation of line which passes through this point and perpendicular to this line. Okay, so basically it's almost the same thing, right? Almost the same thing. But the only difference is that number 16, it is the line is parallel, and for this question number 17, the lines are perpendicular. Okay, perpendicular. Okay, so when two lines are perpendicular, let's say I have m1 that is equals to a over b, then if m2 is perpendicular to m1, so which means that m2 will be minus b over a. So you only need to swap the a and b, right? And then if one is positive and the other will be negative, right? So for example, if I have a line like this, let's say this is have a negative gradient because it's going downhill, and the other one is going to be, if we have another line which is perpendicular, it will be like this, right? Because perpendicular means that it makes a 90-degree angle, right? So this is going to be positive, right? Because you can see, right? So because this is uphill, right? So that's why one is negative, one is positive. Okay. Okay. So if we can do the same thing like before, which means that again, if I illustrate that, I have a line. This is L1, for example, and that passes through that point 3 over 4 and 4 over 5. Yeah, that point B. And then we have another line which is perpendicular to that. So I'm going to draw a line which is perpendicular. Let's say the perpendicular is in here. Okay, perpendicular. So this line equation is this guy here, right? So how can we, because again, when we want to construct a line equation, we need gradient and a point. We have the point, but we don't have the gradient yet for the L1, yeah? So we need to find the gradient of L1. How to do that? We find the gradient of L2 first, right? So let's find the gradient of L2. So we know that we have this as the line equation of L2. We have 4x plus 5y equals to 12. And to find the gradient, remember that you only need to swap. I'm not gonna swap, like what do you call it? Construct. I mean, like, yeah, move all of the things that is not y, this one and this one, to here, right, to the right side. So I will get that will be 5y equals to minus 4x plus 12, right? If I move this one here, and then that's 5, I'm gonna move that, becomes minus y equals to minus 4 over 5x plus 12 over 5. Okay, so that is for L2, yeah? This is for L2. Okay, so which means that the gradient is this one, right? That is going to be the gradient of L2. Okay, so because we know that L1 is perpendicular, we go to this concept, right? So which means that the M1, right, M1 is going to be 5 over 4, right? You see, you only need to swap the 5 over 4. And since that M2 is negative, then this one will be positive. Okay. Okay, so you have a gradient and then you have a point. And then you only need to do the same exact thing like we did before in here. Okay, so you do it yourself, you can do it. Now let's go to the next question. Okay, I'm not going to show you the answer for this one. I'm gonna explain the concept. Yeah. Okay, so we have A, B, C, D. Okay, we have that A, B, C, D. Here we have point A, point B, point C, point D. Right? And then it said that it shapes a parallelogram. So if it is a parallelogram, it means that this line and this line will be parallel. And this line will be parallel with this one. Right? Okay, so given point that A is 3, 1, and then we have B is 9, 3, and we have C is 4, 6. Okay. Oh, sorry, not there. That's not C. That is the D. Okay. Now this is 4, 6. Okay. And then determine the value of B. We don't know the coordinates of this line, right? So how can we do that? We can just like, okay, because let's say this line over here, this G line, right? This line over here is parallel to this one, which means that we know that if two lines are parallel, it means that the gradient will be the same. Okay, so let's find the gradient of this one, and then let's connect that to this one later on. Okay, so you find, the first thing you do is to find the gradient of AC, right? Find that. Okay, so again, the first one is we need to find the gradient of AC. So let's say this is x1 and y1, and this one is x2 and y2, right? So I will get that becomes 6 minus 1, and then 4 minus 3. Right? 6 minus 1 is 5, and 4 minus 3 is 1, so the gradient will be 5, right? Yeah, okay, so that 5, the gradient of this line is 5. So the gradient of this line is also going to be 5, right? So we can find the gradient of BD, right? If this is xy and this is 9, 3, so the gradient of BD will be equals to y minus 3, right? Y minus 3, right? Over, right? X minus 9. That's it. So y minus 3 and over x minus 9 will be equals to 5 over 1. So we can find, oh, this one is equals to this one, and this one equals to this one, right? So we can do it one by one. So we can find the y by using this equation here. This one equals to this one. So I will get y minus 3 equals to 5, then y equals to 5 plus 3, and y equals to 8. I get the value of y. And then I can get the value of the x by using this one. So I will get x minus 9 equals to 1. So x is equals to 1 plus 9, and x equals to 10, right? So which means that we can have a conclusion that the coordinates of D will be 10, 8. 10, 8. Okay, we're done.